Hello everyone, in this question we have a polynomial px equals ax cubed minus 9x squared plus bx minus 6, where a and b are constants, has a factor of x minus 2. The polynomial has a remainder of 66 when divided by x minus 3. Part A, find the value of a and of b. So to solve this problem, we need to employ both the factor theorem and the remainder theorem. So for a factor theorem, if p a equals 0, this implies that x minus a is a factor of your polynomial. So given that we have a factor of x minus 2, this is implying that p2 equals 0. So using this information, we'll form an equation. In the second part, it says the polynomial has a remainder of 66 when divided by x minus 3. So from our remainder theorem, that implies that P3 equals 66. And this will form our second equation. So let's write our first equation down. P2 equals 0. So we'll substitute 2 into the equation. So we can write P2 equals a times 2 cubed minus 9 times 2 squared plus b times 2 minus 6. So that will simplify to 8a minus 36 plus 2b minus 6. And down to 8a plus 2b minus 42. So from our original statement, this would be equal to 0. So we can write 8a plus 2b minus 42 equals 0. So let's rearrange it to 8a plus 2b equals 42. Let's simplify by dividing everything by 2. So we'll get 4a plus b equals 21. This will be our first equation. From the remainder theorem, we stated that P3 equals 66. So let's substitute 3 into our equation. We'll have P3 equals a times 3 cubed minus 9 times 3 squared plus b times 3 minus 6. So we'll have 27a minus 81 plus 3b minus 6. So that would simplify to 27a plus 3b minus 87. So this will be equal to our remainder, which is 66. So we can write 27a plus 3b minus 87 equals 66. So when we simplify, we'll have 27a plus 3b equals 153. Let's divide this equation by 3. That will give us 9a plus b equals 51. This is equation 2. So let's save some space and write down our second equation here. We have 9a plus b equals 51. That's equation 2. So let's subtract these equations. 9a minus 4a is 5a. b minus b is 0. And 51 minus 21 is 30. So in this case, a equals 6. This is your first answer. We will substitute back to equation 1 and we can find b. So we'll have 4a, and a is 6, plus b equals 21. So we'll have 24 plus b equals 21. So b will be equal to -3. And we need these two answers for the second part. So in part B, using your values of A and B, show that Px equals x minus 2 times Qx, where Qx is a quadratic factor to be found. So from part A, we know that A equals 6 and B equals -3. So let's substitute these values into our polynomial. We'll get Px equals 6x cubed minus 9x squared minus 3x minus 6. And from our previous section, we know that x minus 2 is a factor. So we can divide that into the polynomial. So we'll divide in x minus 2 into our polynomial, 6x cubed minus 9x squared minus 3x minus 6. So our first quotient term will be 6x squared. 6x squared times x is 6x cubed. 6x squared times -2, -12x squared. Then we subtract. 6x cubed minus 6x cubed is 0. Minus 9x squared plus 12x squared. That would be 3x squared. Drop down the -3x. So our next quotient term will be 3x. 3x times x is 3x squared. 3x times -2, -6x. Then we subtract again. 3x squared minus 3x squared is 0. -3x plus 6x will be 3x. And drop down your -6. So the last term of our quotient will be 3. 3 times x is 3x. 3 times -2, -6. And when we subtract, 3x minus 3x is 0. -6 plus 6 is 0. So this is our remainder as expected. So the quadratic factor we wanted to find is 6x squared plus 3x plus 3. Let's go to part C. Part C says that hence show that the equation Px equals 0 has only one real solution. So from part B, we can write down Px equals x minus 2 and 6x squared plus 3x plus 3. So this is our linear factor and this is our quadratic factor. So let's rewrite the polynomial in equation form here. So we'll write x minus 2 times 6x squared plus 3x plus 3 equals 0. And we need to show it has only one real solution. And we know that one solution comes from here, x minus 2 equals 0, so x equals 2. So this is our only solution according to the question. We need to show it's the only solution, which means we need to show this quadratic factor has no real solution. And to do that, we'll use the discriminant. So let's write our expression again, 6x squared plus 3x plus 3. Now we can use the discriminant. The discriminant is b squared minus 4ac. Now if this discriminant is negative, we'll have no real solution. So in this case, a equals 6, b equals 3, and c equals 3. So let's substitute these three values into our inequality here. We'll have b squared, which is going to be 3 squared, minus 4 times a is 6, c is 3. We need to check if this is less than 0 or not. So that will give us 9 minus 72, less than 0. 9 minus 72 is negative 63, less than 0, and this is true. So that's indicating that our quadratic equation, 6x squared plus 3x plus 3 equals 0, has no real roots. So the only root that exists is from this first factor, which was x minus 2. Thanks for watching.